Hello everyone, welcome to this session of online lecture. In previous lecture, we have completed the complete structure of human respiratory system. Now we know how human respiratory system works. We know what is the mechanism of breathing. Today we are going to study a concept related to this mechanism of breathing and respiratory system. Today we are going to discuss two terms which plays a very important role in NEET examination. The two terms are respiratory volumes and another is respiratory capacities. So let us start with respiratory volume. You may be thinking, what is meaning of respiratory volume? See, normal mechanism of breathing we have studied. We take in air, we give out air. Now suppose what lungs will be doing during this. Lung will receive air, lung will hold certain amount of air, lung will expel air. All these three terms, lung receives, lung stores, lung expels. It receives certain amount of air, it holds certain amount of air, it expels certain amount of air. That whatever amount of air comes in, whatever amount of air stays in, or whatever amount of air goes out, that amount of air in these three different mechanisms or in these three different steps is called as respiratory volumes. So you can see the definition here. The quantity of air lungs can receive, lungs can hold under different conditions. Three terms I am telling. Lungs can receive, hold or expel under different conditions is called respiratory volume. Clear? So respiratory volume is, it is volume of air. It is quantity of air which lung receives, which can lung hold or which lung can expel. Remember these three terms. And there are different types of respiratory volumes. The first type of respiratory volume which we are going to discuss is tidal volume, that is T. You know, we humans, when we breathe, we normally breathe 12 to 16 times in a minute. Normally, if you count, you will come to know. 12 to 16 times we take in air and give out air, that is normal breathing rate. And during this normal breathing rate, we take in air, we give out air. During normal breathing, whatever amount of air we take in and whatever amount of air we throw out, that volume is called as tidal volume. You can see the definition. Volume of air inspired or expired during normal respiration. This term is important. During normal respiration, whatever amount of air we take in and give out, that is tidal volume. The approximate tidal volume is 500 ml per breathing. Per breathing means once you inspire and expire. That is single breathing. During a single breath, the normal tidal volume is 500 ml. As I said, a normal human breathes 12 to 16 times a minute. So if you multiply this 500 into 12, you will get 6,000. You multiply to 16, you will get 8,000. So normally a person's tidal volume per minute is 6,000 ml to 8,000 ml. Just multiply this value with 12 to 16. So approximate breathing rate, approximate tidal volume per minute is 6,000 ml to 8,000 ml. That is 6 liters to 8 liters per minute. That is our normal tidal volume. Moving up forward, after tidal volume, another definition comes, that is inspiratory reserve volume, IRV. Now see, during normal breathing, we normally take in air, we normally give out air. But we have a special capacity. We can do forceful inspiration. See, you can take maximum possible air inside. Whatever maximum possible air we can take inside after a normal expiration is called as inspiratory reserve volume. Means additional volume of air that person can inspire during forceful inspiration. Forceful inspiration. Suppose if I tell you, you have to pause your breathing, you have to stop your breathing for next 30 seconds. You will not directly stop. What you will do? You will take a long breath and then you will stop. Means whatever long breath you are taking, that extra amount of air rushes in. So that forceful inspiration is called as inspiratory reserve volume. Lungs will expand, it will hold air. So that is maximum quantity of air, and normal inspiratory reserve volume is 2,500 to 3,000 ml per breath. approximately 2.5 liters to 3 liters. You can see our normal tidal volume was 500 ml. Inspiratory reserve volume is 5 to 6 times greater than the tidal volume. This term you have to remember, 5 to 6 times greater than the tidal volume. This type of statement can come in NET examination. Coming to the next definition, that is expiratory reserve volume, ERV. Exactly opposite to inspiratory reserve volume. The amount of air which you breathe out forcefully. Suppose you have to blow a balloon. While blowing a balloon, you can forcefully blow air into that. So after a normal inspiration, whatever amount of air you forcefully throw out, forcefully, additional volume of air that person can expire during forceful expiration is called expiratory reserve volume, and its average value is 1000 to 1100 ml, exactly opposite to inspiratory reserve volume. So whatever after breathing, suppose if I breathe in, breathe out. You can see this next definition, residual volume, I am talking about it. Volume of air remaining in the lungs even after forceful expiration. Suppose if I breathe in and I forcefully throw my air out after expiration, complete 100% air will not come out. Lung will hold a certain amount of air, and that amount of air is called as residual volume. In circulation also we have seen, after pumping, heart holds certain amount of blood in it. Same thing, whatever air stays in the lung even after forceful expiration is called as residual volume. Its quantity is 1100 to 1200 ml. So respiratory volumes we have discussed. Respiratory volumes means it is quantity of air lungs can receive, hold or expel. Remember these three words. These three quantities represents different respiratory volumes. First one we studied, tidal volume. It is related to normal breathing. Normal value is 500 ml per breath. If you count per minute, you have to multiply it by 12 to 16. The answer comes to 6000 to 8000 ml. Second one we saw, inspiratory reserve volume. It is quantity of air coming in the body, coming in the lungs during forceful inspiration. It is nearly 2500 to 3000 ml. Third one we study, that is expiratory reserve volume. It is due to forceful expiration. Quantity was 1000 to 1100 ml. So after doing forceful expiration, whatever amount of air remained in the lungs, it is called as residual volume. Its quantity is 1100 to 1200 ml. So these are the four different respiratory volumes. Now when you combine these different respiratory volumes, combinations of different volumes forms a new term called as respiratory capacities. So respiratory capacities, it is combination of various different types of respiratory volumes. See, you may get confused. Respiratory volume I have mentioned here R, and I have written here P, respiratory volume. Residual volume is RV. So you can get confused between these two terms. So wherever respiratory volumes become, I have written here RP.V. Okay. So respiratory capacities is combination of different types of respiratory volumes. There are different types of respiratory capacities. Here we are going to calculate also. First one is inspiratory capacity. It is termed as IC. Total volume of air person can inspire after normal expiration. Total volume of air the person can take in after normal expiration is called as inspiratory capacities. Mathematically, it is represented as inspiratory capacities, that is IC is equal to TV plus IRV. TV means tidal volume and IRV means inspiratory reserve volume. So inspiratory capacities is combination of tidal volume and inspiratory reserve volume. We are going to calculate the value here. Take the maximum possible value. Tidal volume is 500. I am writing here 500. IRV, it is, you can see 2500 to 3000. I am taking maximum value, that is 3000. So value comes nearly 3500 ml. So IC of lung, inspiratory capacity of lung is 3500 ml. So while calculating, take the highest possible value. Next one is expiratory capacity. See, it is nearly equal to inspiratory capacity. In inspiratory capacity, IRV was there, here ERV will come. TV is common, okay. So expiratory capacity, total volume of air the person can expire after normal inspiration. So it is combination of tidal volume and expiratory reserve volume. You can see the mathematical equation. Same way to calculate, tidal volume is 500, ERV come here, so you can see ERV 1000 to 1100, will take maximum 1100. If you calculate this, you will get 1600 ml. So you can know now expiratory capacity is 1600 ml and inspiratory capacity is 3500 ml. These are two terms. Then we are going to take a new term called as functional residual volume, FRC. Volume of air remaining in lung after normal expiration. Volume of air which remains in lung. Here we have to combine residual volume and expiratory reserve volume. Residual volume and expiratory reserve volume. If you say expiratory reserve volume, you can calculate now. You know residual volume maximum is 1200. Expiratory reserve volume, we know maximum value is 1100. If you add this, you will get 2300, means 2300 ml, 2300 ml. These are standard values which can come for MCQ. Next term we are going to see vital capacity. Vital capacity is maximum volume of air person can breathe in or out. I am taking two ways, two definitions are there. See, first definition how I am reading. Maximum volume of air a person can breathe in after forceful expiration. If you take in, you have to mention expiration. Or maximum volume of air that person can breathe out after forceful inspiration is called as vital capacity. It is combination of ERV, IRV and TV. Now we know all these values. ERV, if you calculate, what is ERV? See, IRV is 3000. If you see ERV's maximum value is 1100, TV is 500. Now if you add 3000 plus, that is 4100 and 4600. So this value is 4600 ml. You can write different definitions, you can derive different definitions. We are going to discuss after this formula. Okay. Now see, total lung capacity. Whatever volumes we have studied, if you add all that volumes, it is called as TLC, that is total lung capacity. Here you can add and see TV tidal volume is 500. These three values, IRV, ERV and RV, here we have derived it. So we can directly write here 4600 ml. Adding 4600 ml into 500 is 5100 ml. This is total volume. So these are total different terms which we have studied. Now students, we are going to write different formulas. We are going to derive different formulas. See how. If you see this total lung capacity, TLC. What we have written there? We have written tidal volume plus IRV plus ERV plus RV. If you calculate these three together, you can see IRV, ERV and TV, they are called as VC. So we can write like this. Total lung capacity is TV plus VC. Another formula we have derived here. We can create as many as formula you want. If you see, if you mention RV plus ERV is FRC. Means RV plus ERV, it is called as FRC. So you can write like this also, TLC equal to TV plus IRV plus FRC. So you can derive different formulas here. In this lecture, I will suggest you to go through all this definition, all the terms. In next lecture, we are going to discuss what is spirometer reading, and during that we will revise all this formula and we will derive additional formulas too. I have given one hint how to derive an additional formula here. And looking at this forceful residual capacity, in athletes, sports person, this capacity is maximum. Due to more workout, their capacity is comparatively larger. In comparison with male and female always had 20 to 25% less respiratory volume and respiratory capacities as compared to male. So female on average, both respiratory volumes and respiratory capacities both are 20 to 25% less in females. And FRC, this one, FRC and RV, that is residual volume. These two cannot be practically counted by any instrument. Except these two, FRC and RV, except these two, all volumes and capacities can be calculated by an instrument called as spirometer. In next lecture, we are going to discuss what is spirometer, how its graph is, what is its normal graph, and along with that, we are going to revise the different formulas once again. Okay, thank you.